All right, so guys, in this part of chapter 13, we're going to solve the equation of motion using cylindrical coordinates. Now, what are the cylindrical coordinates? They are UR, U theta, and UZ. How to generate this equation of motion using the cylindrical coordinates? Of course, guys, we know that AR and A theta, they are in terms of R and the derivative of R, as well as theta and the derivative of theta. So if I know, for example, R double dot R and theta dot, I can find AR, and then I can do the free body diagram and find the equation of motion in radial direction and so on. Remember, guys, AR and A theta, they are both in terms of the derivative of R and the derivative of theta, while AZ is only MZ double dot. All right? Now, if I know AR and A theta, like let's say in the polar coordinates, if I know AR and A theta, I can apply the scalar form of equation of motion in radial and transverse direction. All right, guys? Now, I want you now to pay attention to this slide. So I am, guys, in the cylindrical coordinates. However, I'm going to use the normal and tangential forces, or the tangential notation, a little bit to help me in doing the projection of the forces in cylindrical coordinates. I know, guys, in fact, that the normal force should always be perpendicular to what? The normal force should always be perpendicular to the support. All right? So if I have a support, guys, the normal force should always be perpendicular to the support. Now, what if this support is a curved path? So if this is a curved path, so this support is curved, then what I should do is to draw the tangent like this one. This is the tangent at this point on this curved support. And in this case, the normal force will always be perpendicular to this tangent. So the normal force will be always perpendicular to the tangent. All right, guys? Okay, so if I want to apply the equation of motion in cylindrical coordinates, what will be UR? UR will be along R to the outside. So this is UR. Of course, I'm exaggerating UR because this is a unit vector, so it should be very small. It's okay. All right. So this is UR. Now, what is the U theta? It is perpendicular vector in the direction of theta, so this will be U theta. Okay, guys? And I want to do sum of FR and sum of F theta in order to find my unknown. All right. So I'm going to do sum of FR is equal to MAR. And sum of F theta is equal to MA theta. However, guys, if you take a look on the normal force, so this is the normal force. If you take a look on this normal force, guys, can I know the projection of this normal force on UR or on U theta? And I know the projection of this normal force on one of these two directions so that I can do the equation of motion. In order, guys, to know the projection of this normal force, which is always perpendicular to the tangent direction of the curved path, I should know at least one angle. So if I know, for example, this angle, or if I know the angle between the normal and U theta, the angle between UR and the tangent. So if I know the angle between UR and the tangent, and I'm going to call it xi, I can say that this xi is the same as the angle between N and U theta, all right? So it is the same as this angle because U theta is perpendicular to UR and N is perpendicular to the tangent. So if I know this xi, in fact, I can do the projection of the normal force on UR and on U theta. Is that clear, guys? Is it clear? Any questions so far? Any questions so far, guys? All right. So I'm gonna repeat, guys. My objective is to do the projection of the normal force in radial and transverse direction. However, guys, I don't know any angle. All right. So, Batul, if you cannot see your screen, I advise you to leave the session and to read again. So I don't know, guys, this angle. I don't know any angle between the normal force and UR or the normal force and U theta. In order to find out what is this angle, I have, guys, to do some differentiation. Guys, I am saying that I need to find the angle psi. And this angle is between UR and the tangent to the path, right? And this one. Now I know, guys, that this angle is equal to this angle vertically opposite, altern and tan, all right, guys? So this is also psi, all right? So if this is psi, then this is also psi, vertically opposite. Now how to find tangent to psi? Tangent to psi is this one right here, this distance which is r d theta over this distance which is dr. So tangent to psi is equal to r d theta over dr, all right? Now, if I take this d theta to the denominator, then tangent to psi will be equal to r over dr over d theta. Which means, guys, if I know r in terms of theta, I can find dr, the derivative of r with respect to theta, I can find psi. Now, whenever I know psi, what is this psi? This psi is, in fact, the angle between what and what? This psi will be the angle between the tangent to the path with UR, which is, in fact, what matters for me is to find the angle between the normal and one of these two directions, which is, in fact, the angle between the normal force to this path and U theta, right? Because, in fact, N is perpendicular to T and U theta is perpendicular to UR, all right? So I'm going to repeat, guys. If I know R in terms of theta, I can find dr over d theta, I can find r over dr over d theta, I can find tangent psi, I can find psi, and psi will be the angle between the normal force to this path and u theta. Okay? Clear? Now, what if I don't know r in terms of theta and I need this angle? In fact, guys, if you don't know r in terms of theta, but you know r in terms of t, of time, and make sure, guys, you recognize the difference. R dot is not r, is not the derivative of r with respect to theta. R dot is the derivative of r with respect to time, all right? So if I know the derivative of r with respect to time, I can find the derivative of r with respect to theta. Because I know, guys, that dr over d theta from the chain rule is equal to dr over dt times what? Times dt over d theta. Now, what is dr over dt? R over dt is r dot. And what is d theta over d? What is d time over d theta? It is 1 over theta dot. Because theta dot is d theta over d time. Which means, guys, that dr over d theta could be found also using the derivative with respect to time. It is r dot over theta dot. All right. So as a recap, guys, if I am in cylindrical coordinates, I should do the equation of motion. All right. So if I want to do the equation of motion, I may face, not all the cases, but I may face a normal force. And this normal force is perpendicular to the curved path. So what I do to find the projection of this normal force on unit vectors of the cylindrical coordinates. What I should do is, in fact, to find an angle. And this angle is called here psi. It is the angle between the tangent to UR, or it is the angle between the normal force and the transverse direction U theta. How can I find this angle? By doing tangent psi is equal to R over the derivative of R with respect to theta. All right, guys, everything is clear?